Wonderful.
So
So
epic.
let's open the gates. Yay.
Yay.
Good luck. And oh, Bibi is here. Wonderful.
Yay. Nice.
Um,
It will be amazing. Good luck.
I don't sure. Bibi. Let's make Bibi co-host before. Yes.
Yes. And you introduce first, right, Gigi? And then I take it over.
Yeah, I'll do a very short introduction. Yeah.
Perfect.
Okay.
Hi, everyone.
Hey, 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 Bibi. How are you?
Great. Nice to see you.
Yeah, I see sunny vibes. So we're letting everyone in. Nice. Pretty cool. I think
Wonderful.
some
Welcome,
people
everybody.
Yeah.
We're just letting everybody in and waiting for a couple of minutes before we start. In the meantime, feel free to add something in the chat. Anything you like, maybe like where you're from, where you're based, what your interest is in this topic. And feel free to turn on your camera as well. And let's wait for a couple of minutes more.
Nice to see that a lot of people are joining. Exciting. I see some familiar faces. Some other AIs, which is always good to talk about AI with AI processes here. It's actually an emoji of an otter. Cool.
All right, I think it's about time to start, right? Because some other people might be joining us still, but please, my colleagues, feel free to add them into the room. For now, I will start with a warm welcome. I'm really excited to have this session finally after a long time of preparation. We are now starting with our first session of the AI learning series. This is a collaboration between RNW Media, who is basically the initiator and also the crafter of the course, Forres and Partos. And in this first session, which is an open session, we will be diving deeper into AI and what it means for basically our sector, who is aiming to work towards like a more equitable and social future. But what does it mean for civil society organizations? Well, that's basically what we're going to look into today. I just wanted to say a little bit about Partos before we start, because some of you might not have attended a session from Partos before. So we are the Dutch umbrella organization for organizations working in international collaboration. We are a learning platform where we bring together various organizations based in the Netherlands, but also abroad, to facilitate and motivate organizations to be more innovative and inclusive in their working approaches. And we do that on several topics and themes. So one of them is on data and digitalization. But next to that, we have topics focusing on climate justice, on decolonization, shifting power, inclusion, diversity, equity, and inclusion within organizations. So a lot to explore. So if you haven't yet heard of us, have a look at our website. I'll post something in the chat later on. And for now, I'm going to quickly move on this conversation to Fer from RNW Media, because they are the ones who actually hold the knowledge and will share a lot of exciting things today. So it was just an informal opening from my end. We'll now move into the formal part. Please take it over. And yes, that's it.
Thank you, Gigi. For sure, I think the knowledge is something we will create together, hopefully in this session and in next ones. So thank you, Gigi, for this opportunity and the space for collaboration. I also want to thank Photos, of course, because it has been a lovely and inspiring process. Thank you, all of you, for being here. Yes, we will talk about AI. Before that, I want to give a quick shout out to my colleagues. Noyan and Shaukan are here. They're going to be also co-facilitating with me. They're really the experts that know the techie stuff. And of course, Bibi, in the end of the presentation, as part of Photos, will also share a little bit about their work on the Ethical AI Civil Society Manifesto, which is super interesting, and we'll have a good time for that. Lutza is also here. She's also part of the learning team of RNW Media, and she will be facilitating a little bit or moderating the chat. So if you have questions or insights or ideas, just please feel free to put them in the chats, and she will interrupt me or Noyan or Shaukan when it's necessary. So yeah. So welcome to the AI Learning series. The objective, very briefly, of this series is, as Gigi mentioned, to offer non-governmental organizations in the development sector to approach AI with a little bit more general understanding of what is AI, what are the technologies behind it, how does it work, what are the ethics, what are opportunities also in terms of applicability, but also what are the opportunities for the push that we need to do in relation to governance on AI. So our series, this is the first session, and as Gigi mentioned, it's an open one, so it's a free one. But we will have 5 online masterclasses of 2 hours, and hopefully our approach will provide a little bit more of an intuitive understanding of AI, especially in reflection, because this is really related to our work. What are the socio-technological aspects and the political implications of AI in relation to social justice, and our interventions as we work in this field. Yeah, in the end of the session, I'm very proud to share that Photos will present their civil society manifesto. So also, if you have some questions formulating throughout the session, please make sure to write them down and share with them. Okay, our first session is called Understanding AI, Programs, Powers, and Global Perspectives. By the way, I see that someone is in the waiting room, so if you can let them in, I think that would be great. Yes, the idea is that we want the kind of a backend to start with some fun jokes. We want to know the backend of programs. How do they work? What is the mechanisms that AI is using, and how are different technologies being deployed, but also how they are trained. And in some sense, we also want to reflect in a contextualized political way what these technologies are doing. So we can also, this is our kickoff session, but we are also starting to think about the implications in relation to power and data, bias, harm, algorithmic violence, etc. And of course, global perspectives, because yeah, this is a conversation that we need to have globally, and where we will talk about it a little bit later, but where the stakeholders, the people who make those decisions, have a little bit more diversity in the voices. I think that's really crucial for us to think about now. So first, some practical things, just kind of like to try to make the virtual space a little bit more embodied, although it is of course embodied. We ask or suggest to have your camera on but microphone off, unless you want to, when you want to talk, of course. I also want to ask for some activities that we're going to do, because we'll have some spaces for discussions and interactions with the chat. Just have a note document in your computer kind of ready, word processor, texts, whatever you want. A browser, of course, and then critical minds, practice oriented. Okay, but before we start, a little bit of interaction via chat. I want to propose breaking the AI ice. So I'm gonna ask 3 questions to everyone, and I'm gonna ask you to write them in the chat. Don't send the answers yet. And when the 3 questions are ready, we can send them at the same time and see what happens, okay? So yeah. Oh, question, Gigi, are you recording the session?
Yes, the session is being recorded.
Oh, great. Okay. So just for everyone to be informed, we're recording this session for anyone who cannot join right now, especially because this is a free session. But just so that you know, we're only recording the screen presenting and the people speaking. So yeah, if you have any things to ask or something, this is the moment as well. But otherwise, let's go for the icebreaker. So first question. When you think of AI, what is one word that comes to your mind? You can just think about it for a moment. Whichever words, we have, I think, 44,000 words in the English vocabulary. So yeah, don't send it yet to the chat. And then you can click shift and enter, and that will go a little bit lower without sending. Second question. What is your own definition of AI? And please, please, please do not use AI for this or Google it, just as a kind of test. How do you explain AI right now? I hope that this changes in the end of the session. I give a little bit of more time for this one. If someone finishes and can give me a thumb up, I can continue. I see a lot of focused faces, which is good. Hey, Abir, you're here. I'm so happy. So thumbs up. Are we ready for the definition with AI? Yay, amazing. And so third question, on a daily basis, how many times do you think you come in contact with an AI? Like it doesn't have to be a number. You can also say like, okay, ChatGPT. But think of other instances, scenarios, interactions that you have that you think are being mediated or use some sort of artificial intelligence technology. And again, a quick one thumbs up, I can continue. Some reflections. Thank you for all of you who have, thank you, Florence. I will take her cue and continue. So if you can all please enter and put them in the chat. Let's see, some people already did. Okay, I'm gonna read them out loud so that they're in the screen recorder. New opportunity, robots. Many times I spend a lot of time on a laptop. Customer bots, unequal as a words, linking knowledge in a logical way, great. Constantly, data, advanced ChatGPT several times, targeted advertising, great. Transformation, every nanosecond went behind, wow, Gigi. Speed, 10 plus, exploitation, great. I already see this discussion is going to be amazing. Powerful, yeah. AI is a new revolution. So I see power, I see robots, I see horizons, I also see Inspiration, that's great. Learning, scary. I agree, Maureen, can be really scary. Has a learning brain. Okay, I like that because we're going to talk about the parallelisms between brain architecture and technological architecture. Okay, so 5 times, BB. I think that was a little bit not so realistic. We will see. But non, but a lot. Terminator. I love this. Okay, I'm going to admit someone that I think is in the waiting room. Okay, thank you for those inputs. But I think we can have some of keywords, right? So like they think, they learn, they decide, they're powerful, they're unequal. So these are all kind of keywords that I think are going to come back because of course we're reflecting on AI, but in the context of social justice. So I will come back to these questions. But our agenda of today is we're going to have an introduction, 2 hours, some case studies, some reflections, some discussions. I would like to request for us to be present and to remember that technology is what we make of it. And right now we are making a space to reflect and think together about it. So I'm really, really excited. We're going to go a little bit of what is AI, so history, algorithms, data. What are different models? Machine learning, deep learning are the 2 main models that we're going to try to explain. Generative AI, specifically large language models, and of course, that joke that cannot be missed without whenever I do things, AI in conversation, so Foro Civil Society Manifesto. This will be briefly 2 hours with consideration of a buffer time for us having discussions. So we really want to make that space for us to talk together. So I'm gonna go for it. So AI human interactions. Let's think of some moments that we interact. Social media, of course. An individual between the ages of 20 and 40 spends 2-3 hours on a daily basis on social media. So algorithmic recommendations on platforms like YouTube, Netflix, Facebook, and the impact that we can think of course, is like the influence on public opinions, right? We all know like the algorithm of social media and the bubbles that it creates and the polarization effect that it's having right now. E-commerce and marketing, of course, personalized advertisement. We've all been victims of how did Amazon know that I wanted to buy this or that product? And I think here is more talking about the manipulation of consumer choices and some privacy concerns of all the data that is being shared without our explicit consent. Of course, smart devices, home assistants, Siri, Alexa, anything that you have that you ask for it, something. Google Home, for example, take me to the nearest pizza place. That's also an artificial intelligence. But we can think about less in a personal, individual way and a little bit more in a social, political sense. Healthcare, diagnosis aids, treatment recommendation systems. Right now, there's also a little bit of that going on in health insurances. I think not in Europe, but for sure in the US. That's a big discussion right now. Financial services, credit scoring algorithms, algorithmic training. We can also think of workplace and HR, recruitment tools, surveillance issues, performance monitoring. So these are all moments that we're going through. And of course, transportation and urban planning. There's a lot, especially now with self-driving cars. There's a lot of smart traffic management and also kind of routing systems that they try to analyze how people behave when driving in specific times. So all of these are moments that we're interacting with AI. Now let's go. I wanna propose a frame to think, feel about AI throughout the session. If anyone has read Kant, just please bear with me for a tiny second because I will make a huge simplification of his critique of pure reason, but I promise it will make sense. So what AI can't do for us. So making a really, really huge simplification of Kant's philosophical theory of knowledge, right? He was asking, as well as other philosophers, what is knowledge? What does knowing mean? What is the relationship between matter and knowing? So meaning. Kant proposed five faculties to approach the cognitive capacities of humans. Again, if there's any philosophers in the room, please correct me, but and I made a simplification for this. The history of both philosophy and neuroscience can be reduced to this question, right? What is knowledge? And the answer is always, as is going to be proven in this session, way more complex than we would like. But I propose we use these 5 faculties that Kant proposes to ground our reflections about AI, to really understand in an intuitive way what AI is doing and what it can't do. And yeah, so let's think about, for a tiny moment, the body as a technological interface, right? Kant proposed 5 faculties. The first one, the most basic one, he would call a sensitivity. So the first encounters, the bodily senses, how your body is able to relate to the impulses around it and transform it into input for your body to process. The second one would be perception, that is kind of building on the sensation first encounters. So that would be transforming the senses into experiences. Think of low temperature equals cold in your body, and that triggers a series of responses that have nothing to do with cognitive rational mind, right? But it's your body thinking, feeling in a kind of really smart way. Then we have intuition. Kant divided intuition into 2 categories, so sensibility and intellectual, and also a priori and posteriori, but this doesn't really matter. It's more to think like intuition for Kant referred to a non-conceptual way of thinking. So it's something like a gut feeling, if you will. A gut feeling that can be a curiosity when it comes to intellectual endeavors, like, I don't really know that something, but I kind of have an intuition that I have to put some questions in that direction. That would be an intellectual intuition. And of course, a sensible one would be more like, I really like this person. I don't know why, but I like this person. The fourth faculty, of course, and for Kant, this was very important, was rationality. For Kant, this was a capacity of humans to make like causal relations. So if one thing, then another. And that was also kind of a logical categorizing part of the cognitive capacity of humans. In his critique of pure reasons, this is the way that we form judgment, for example, and this is also going to be relevant for AI. And finally, the last one is understanding. So all of them together, and you can understand a situation in all of its complexity, even the things that you don't know, rationally speaking. Of course, these are faculties that he presented a little bit separated, but they all work in relation to each other. What is important to maybe think through this session is that we will see, but mathematicians and scientists define artificial intelligence as it sounds. Let's make intelligence artificial. Let's replicate it. And they only thought intelligence meant our capacity of reason, right? So logical, causal, and categorical. And that's going to be really important. So all of the other faculties, let's say AI, is not really focused on. So first session, first part of the thing, we're going to talk what is AI, so history of the field, some algorithms, so what are algorithms, and the data biases and harm. So I'm just going to jump into it. Okay, so we can say artificial intelligence is actually an interdisciplinary research field. It puts together, like in a Venn diagram, mathematics, computer sciences, and softwares to informational theory, so the psychology behind and the neuroscience part of how our information works, and the engineering parts, right? So together, in the 1956, in a very famous conference, John McCarthy, Claude Shannon, and Nathaniel Rochester, part of Dartmouth, IBM universities, they made a research proposal that was called artificial intelligence. They said it was not a very smart title, their words, but in the end, it was what stuck. And part of the research read, it was based on the conjecture that every aspect of learning or any other feature of intelligence can be, in principle, so precisely described that a machine can be made to simulate it. And I think here are some keywords for you to keep, right? So intelligence understood as rationality, this casual logical kind of approach, can be precisely described. So I can perfectly know and lay out on a piece of paper how does it work, right? Like how my logical thinking works. So then I can codify it into a computer and the computer can simulate it back. So I think, this is, it's really useful because let's say that the aim of artificial intelligence, and this is a keyword, has been to reverse engineer the human brain. There's been like two kind of fields, symbolic and sub-symbolic artificial intelligence that you can ask ChatGPT to explain. But basically it's either we explain how logic works. Let's say that I ask you to solve a puzzle and I ask you to describe to me your process of thinking while you were doing it. And I could put that into a computer and the computer simulates it back. Or I try to replicate how the architecture of the brain works. These two models have been, let's say, lately, the architectural model of the brain became way more successful, and we will see later why. But yeah. So, thinking about this, we can already arrive to a little bit less obscure definition of artificial intelligence, right? Computer systems that use algorithms to learn from data in order to make decisions on our behalf or help us make decisions. Julia Stevanovic is a professor at NYU and has an amazing open course about AI as well. It's quite introductory, but I highly recommend. So it's a little bit less obscure than, right, like robots, although I understand the robot part. But still, when I say what is an algorithm, maybe it's not so straightforward. So I will propose that we do a thought experiment together. So get your notepad ready and let's do some cooking together. So I'm gonna give you a prompt as if you were an artificial intelligence. You are a natural intelligence. So I'm gonna ask you to take 5 minutes to make a recipe for a chicken noodle soup. In your notepad, first, you make a list of the ingredients, all the ingredients that you think you might need in whichever degree of specificity that you want. And two, write a step-by-step list of instructions to make the soup. We are gonna make it really quick, not only because we have short of time, but also because I want the process to be a bit more intuitive, let's say. So I'm gonna give 2 minutes. Potentially, I know that it says 5 here, but time is relative. So I give a little bit of time. Please indulge with me in this exercise. I promise it will be worth it. I see some smiles and some nodding faces. Thank you for keeping your cameras on. It's really nice. And maybe we can make it a little bit of a game. Whoever is ready first and give me a thumbs up. Great, we have a winner. Okay, so let's do this again. Where do I find now the chats? Okay, well, I cannot find my chat, but please share it in the chat. Let me see if I can find it here. Aha, here, great. I see my chat now. Okay, so I see, for example, I'm gonna read the first recipe. Yeah? Water, vegetables such as carrots, celery, noodles. We missed the chicken, but great. And then boiled water, chopped vegetables and chicken, season and let it cook for 30 minutes. Daniel writes ingredients, water, chicken, instructions, put chicken in a large pot, add water to submerge, cook for 2 hours. Great. I wait for one more recipe. But it's lovely. Come on, peeps, one more recipe, and then I can continue, I promise. Thank you. Alessandra, my boss, she has done this exercise several times. And thank you for indulging, Ale. So 200 grams of noodles, 1 liter of chicken broth, 1 onion, 2 garlic cloves, salt, pepper, and spices. Shred the chicken, cut the onion and fry together with garlic, add chicken, add spices, add broth, let cook for 45 minutes, add noodle. Great. So, I mean, it's interesting to see perfecting the recipe every time. Yeah, exactly like a GPT. It's interesting to see, like, if you go through, I know it was a very quick thing, huh? But if you go through, there are so many ways of doing the same thing, right? Let me go back to my, where am I? Yes, I'm here. So, yeah, I mean, there are trillion ways of going about cooking a chicken noodle soup. Right? Let's just think for a tiny moment in a more intuitive way that an algorithm is a little bit like cooking, or cooking is a little bit like an algorithm. Both of them are procedures, so systematic processes designed to carry out an activity. In your case, it was a chicken noodle soup. In another case, it can be a predictive system of recommendation for what post to see next. So let's do a little bit of the analogy. Data, in this case of the recipe, was ingredients, so water, chicken, noodles, salt, etc. The instructions was the step-by-step, how your algorithm is processing the data, right? So the instructions for processing that data. And the result, the output, is the soup ready to be eaten. In this thought experiment that you did with me, alongside the logical process of like what parts are needed, data and instructions on like boil needs to be, water needs to be boiled, etc. There were other processes going on in your mind. So I ask more as a reflection. While you were making a list of ingredients, how did you choose your ingredients? Like maybe it was the simplest, more basic ones, or maybe you thought of the ingredients you had in your fridge, or something like this, or your preferred ingredients, like maybe you don't like garlic. When making the recipe, did you think about the people involved? So where did you source the data, the ingredients from, right? So farmers or local shops, or did you think about, for example, where you will be cooking it, like the friend who has a perfect kitchen for cooking? Or question, did you think who will eat the soup? Because maybe it's not such a tasty soup, you know? So depending on stakeholders and values, right? The people involved and what are the values, so simplicity or quickness, or I want to make this chicken noodle soup for someone who is sick, that will tailor and reflect back on how we do the instructions and what type of data we collect. This thought experiment maybe provides a little bit more intuitive approach to understanding key factors of AI ethics, right? Like, so what data do you choose, why, and how is it sourced? How do you use it? How many points of data do you use? You can add values in the rules. So what did you prioritize when making an algorithm or a soup in this case? And how does that reflect back to the step-by-step? And maybe the stakeholders, especially thinking that the final one, who will eat the soup? Did they ask for the soup? Did they need it? Who was involved in the process of deciding if this was going to be a soup or not? So this is, of course, a very simplistic way of understanding, but I think it's really relevant. So we can think like algorithms also as recipes. So they have data that can come in forms of text, numbers, images, and sounds. Or also, for example, input is also data, the time that you spent in a certain amount of post, if you commented, if you share it, if you like it, right? Important to know that all data in computational programs is going to be translated into numbers. So that's going to be quite important. Then the algorithms is the procedures or instructions for performing a task. And the output is a result. So it can be a classification, prediction, or some actions, right? Filters, we will see. And we also have stakeholders and values. Where are we taking this data from, and where are we using it for? You as a consumer, for example, of social media, do you choose Are you like, do you think you're part of the decision-making process that shows you content? Yes, no, maybe, you know. So you are a stakeholder, but potentially you don't have so much decision power. There are some ways to hack some algorithms. Okay. So now I want to talk a little bit about data, because data is primarily the main source of information that algorithms and artificial intelligence specifically uses to process. So let's kind of think of the basics of data. I'm sure most of you dealing with M&E and research know already all of this. But data is a symbolic abstraction of reality, right? So it captures certain aspects of the world through numbers or symbols. So in that way, already data is a bias in the sense that it's a judgment, it's a categorization of something. At the same time, it also represents the dominant version of the world, the mainstream dominant version, and therefore it reproduces most likely socially existing biases. On a third point, AIs are trained on large data sets that are collected often without consent. And so they bring inherent social biases. And also, yeah, we have a lot of questions there about privacy, security, consent. So if all data is biased, let's say, what do we do? Especially in artificial intelligence or digital technologies, we're talking in algorithmic violence, we're talking more about harm and not so much about bias. So if bias is something that we cannot necessarily avoid, we can think of what the bias of this data does. Does it do harm? Does it do healing? One of some examples of how it could present as harmful, for example, in the allocation of services, right? It works differently depending on the person. Let's say an HR artificial intelligence would select more men over women. I've seen this over and over. The quality of the service, so people get different experiences of the work. For example, facial recognition, working better for lighter skin tones, racial profiling, or cameras, for example, smart cameras that are like, when you blink, then the camera takes a picture or something like this. There's a lot of racial profiling for Asian people. Stereotyping, forcing a biased association. Let's say I asked ChatGPT, what is the life of a CEO? And immediately ChatGPT assumes that CEO is a man. Denigration, of course, and representation. So underrepresenting or overrepresenting a subpopulation. For example, saying that what human is a white cis man. Right, so all of this, we can think about the bias that produces harm in how we are using this technology and how the services are being deployed. If you want to think through a little bit more, I mean, all of our sessions are going to be crossed by ethics, so AI for good, really. We're really taking notice on how, what are the political, socio-technological implications, but on session 4, we will exclusively focus on ethics. So please, if you feel like joining, please join. Open conversation. So I bring back the definition of Julia Stojanovic, and now I highlight a different word. We talked a little bit about computer systems and algorithms and data, right? So we have a little bit more clear understanding of that. But now let's talk about another buzzword, learning. So learning is for the next section, and I'm going to briefly present the session. So we're going to talk about how AI learns. And I put this under the big thing, like quotations. So we can think of what is learning, human versus machine, different types of models of learning, so machine and deep learning, and the different models that there are in deep learnings. I will pass it over to my colleague, Shaukan. So Shaukan, if you want, and then you can just say next every time you want me to change slides.
Okay, clear. Thanks for, yes. So continue with AI. So in the following session, my part, I will talk a little bit deeper about the AI models and also the similarity or difference between machine learning and human learning, and also the subset of artificial intelligence, like those terms you may heard before, like machine learning, deep learning, and also what is, for example, like ChatGPT play a role in this bigger AI world. So in the next slide, Actually, I want to ask a question. I want everyone to reflect on a question like, what is learning? Because we prepared this question before, but interesting when I read the chat, like the result or no, the answers that I first asked, like, what is the word that came to your mind that when you heard AI? Many people wrote down learning. Also, like another keyword is machine. That exactly, yeah, come up with the machine learning, this term. But let's talk about learning first. So, in your mind, what is learning? Like, or in your words, what is learning? Please write down your answer also in the chat, and we can like go over together and also reflect together. Great, something new that I don't know. Gathering new information, acquiring new information, improve, to know something you don't know before. Oh, okay. According to ChatGPT, that's too advanced. That even probably better than my answer later. Growth, right? Yeah. Yeah, avoiding your world. Oh, quite a philosophical answer. Yeah. Nice, great answers. So actually, when I reflect on this question by myself at first, I think try to be like simple. It's more like a copy paste, like a parry action. Then I feel like no, it's more than that. I should also understand, right? I also have emotions, and also I have other things like values and attitudes. That's more than just the observe or see the movement and replying to another thing. So, and also there's something that I cannot maybe explain. Like it's not just this process, but also something already in my mind. This kind of unconsciously feeling or gut feeling. For example, if because I'm based in Amsterdam, so when I see people ride bicycles, then this somehow relatively new when I move here, so I don't have to learn that. I don't have to observe and learn that people fell down and feel hurt, but I know that will be hurt. I don't have to fall down to copy that and to apply, right? So that's already somehow in my mind. But also a process of learning. So I would say try to summarize in a simple word. Learning is definitely a debated topic within neuroscience, psychology, and philosophy. It's a process of acquiring. People also mention acquiring new understanding, knowledge, behavior, skills, values, attitude, and also preference. And also involves emotions and also the capacity of the brain to forget things, right? It's not just always can new things, also about forget things. Sometimes we call it selective memory. And also account for the intuition of direction of learning. But it means that our capacity to know what we don't know and where we can look for it. It also about curiosity, critical questioning of the knowledge we have, and also like same like forget things. Also, we can also include like unlearning into this the whole broad learning concept. So this is about learning, and since people already think that AI is also about learning, and also in the previous quote that also it's a process of learning. So let's maybe go to the next slide to focus on so what is artificial intelligence and what is the learning play role in the whole AI world. So this is somehow a mapping of AI world. And also you can see some popular words like machine learning, deep learning. So this explains briefly the interrelationship with them. I would say like artificial intelligence is a quite broad concept or study. It's like physics. And for example, like thermodynamics is a subset of artificial intelligence, and machine learning is also a subset of artificial intelligence. And also deep learning is also a subset of machine learning. And in the deep learning, we can see there are also different models like discriminative models, large language models, generative AI. And between large language models and generative AI, the intersection is the AI that maybe we are more familiar with. That's the application like ChatGPT or Google Bard or Microsoft Copilot. I would say like when we talk about AI, we feel like it's a term, it's a study or science that getting popular in the 2 years, within 2 years or 3 years, that because of ChatGPT. But actually, we all know that artificial intelligence exists for decades. I can still remember the first time I know this word is almost 14 years ago when I came to the Netherlands for my study. And so there was also another Chinese student who is a senior and help the newcomers to adapt to the new environment. He plays like a mentor. So at first we did a introduction with each other. And he asked what do you study? I said I study marketing. That's quite easy to understand. And I asked him like what do you study? And he said I study artificial intelligence. And my face like okay, and what is that? And he tried to explain, and somehow that's the first time I know this word. And during that time, I feel that's kind of like a robot concept that's far away from me. And but in the past 10 years already widely applying to our daily lives that we may not like notice every day, but actually it exists. By the way, quite bravely, he already did a master back in China, but then redo a master in the Netherlands about AI. I have to say he's quite far-seeing for the future. And now, I'm sure he's definitely in this field, being an expert. So that's a broader concept of artificial intelligence and what is machine learning. It's as I said, it's a subfield of AI, but it focuses on developing algorithms and models that can learn from data. I would say like large amount of data set and also improve over time. And it involves training algorithm on large data set to recognize patterns and make decisions or predictions, even with the new data or with a new scenario. And it has different models. I list the two common models here. One is supervised model and another is unsupervised model. The biggest difference between these two is supervised model use labeled data and unsupervised use unlabeled data. I know it's still abstract, so I will use an example to explain. So what is labeled data? For example, this is widely used in the email system. If you remember, like many years ago, we receive a lot of spam emails, and it goes into our normal inbox, and we need to drag them into the trash or we delete them. And this behavior or this process is actually labeling. So we are labeling the input and output. So with millions of this labeling process or this data, then the machine learns. So which emails are like junk emails or spam emails, which are not. Then now we see that in the normal or a material like service, like email service, there is a box called like junk email or spam email. So the machine already detect them for us. Although sometimes we are still go to the junk email box to find probably there are some valuable, but wrongly detected as the spam. Then we do another labeling again, but the machine will learn for the next time. So this is supervised data. So it's about pairing. So you always has input and output like pairing together. And for unsupervised data, example is we also mentioned like for example, the Amazon recommendation system or Spotify recommendation system or Netflix. So I don't have to give the data, label the data like I like piano music, because I also want to receive a recommendation next time, like violin music or pop music. It just because this week I like this type of music. If this system only use label data, then this recommendation system doesn't exist even. So unsupervised data is changing. So it's learn from your answers. The answer is you listen to a new music and also some details like you finish them or you swipe them. That means you like or don't like this type of music. And with those answers, the unsupervised model learn the pattern, then the algorithm, and it also changing because you also listen to other music, for example. So this is an unsupervised model. Talking about deep learning, so it's even a smaller circle. So it's a subset of machine learning. It's more like a machine try to simulate like a human brain, and to try to use human learning pattern and to find no matter the answer or the rules or the algorithms. And in the deep learning circle, there are, as I mentioned, like discriminative and large language models. I have another slide more focused on this deep learning, the two different models. But I would say like maybe to avoid forgetting. So ChatGPT is only a small part between LMS and generative AI. So it's based on large language models, and then give us answers. That's why we can use natural language to interact with AI. So let's go to next slide. Okay. Yeah, so back to the difference between traditional programming and machine learning. Because because generally I'm also new to AI. When I see AI, okay, I'm also curious, like, okay, what's the difference between like before, like those programmers, like they said, for example, when I use my computer, I double click or I right click, it gave me different like answers or next actions. But with today's machine learning, that like I can directly use human language to talk with computers or with ChatGPT, the chat box. And so the difference is traditional programming, you need to have the input or the data, and also you have the rules. And so it has a threshold. You need to be a somehow developer. You need to know the computer language to talk with the system. And then it will give you the answers. But of course, like those operational system is already transformed to like simple shortcuts or clicks. But if you want to change that, you need to know the language. But now with AI, you don't have to do that. You can use like natural language, like human language, to talk with the computer. So machine learning is about not give you the answers. It's rather give you the rule, give you the answers, and give you the rules. It's more like what I mentioned, like the music or content recommendation system. Like you have answers, but you yourself even don't know rules. But the machine will give you the rules and also change the rules afterwards. So it focuses on like learning patterns and the relationship between the data, and also not providing the exact rules, but more provide algorithm that also that somehow, if it's proved, then it can be used to generalize in the unseen scenarios or with the unseen data. So that's somehow the difference. So to give us some examples, for example, for traditional programming, it's like a light button. So open is open, and close is shutdown is a shutdown. but machine learning is more complex. It's more like could be like smart and light system. So it has a sensor. If you come into the door, and then the sensor get to know like, okay, there's a people, not a cat or not a dog, then the light will turn on. But of course, this process, it get to know this sheep is people. But some at the beginning, it maybe like not that accurate because okay, a kid get in, then machine may not answer that, oh, that detect that's a people. But gradually it learned with the answers, they find the patterns. They could be children or adults. Then it give more and more rules and also improve time by time. I hope that's helpful to answer the difference. Let's go deeper into the machine learning.
Yeah, just before, very quickly, Luca, you had the hands raised.
Oh, yeah, sorry. Lucia?
Yeah, thanks. No worries, Xiaokang. There was just a question in the chat from Gigi. He was asking if there are examples of how machine learning and deep learning can be applied in social justice and international projects. BP actually gave an example, and I just wanted to ask for your thoughts about it, and also if anyone has any other examples, then please add it to the chat.
Nice. Yeah, I mean, I think we can all continue reading the chat and continue the presentation because we don't have so much time. But it was a great.
Perfect. Thank
Yeah,
you.
thanks, Gigi. Yeah.
Okay, so I continue. Xiaokang.
Yeah, thanks. Okay. Yeah, so let's talk a little bit more about deep learning. Machine learning. So I would say it has 4 steps. Yeah, basically, or simplify to see. So the first one is training, but also for the training, you're training the data. You have to prepare some data. You need to collect the data. That the data should be relative to the system want to answer or want to solve. And then with the data, normally we'll split or separate 2 sets. One is training data and another is validation data. And and also, of course, during this process, you need to do some like process, like clean the data, reorganize data, standardize the data, or generalize the data. And the data can be different format. It can be text, it can be image, can be video, audio, can be numbers. So with this data and this model will be trained, and then somehow it will find a pattern or a algorithm. With this pattern, the pre-trained map pattern, it will go to the next step, which is validation. So it need to pass a quiz, like a test, like small test, and then to see, okay, if it is not good enough or you find some new patterns, then it will better the model in this step. And after this step, it has a testing stage. That's the one before really applying to the real world. So if it passed the test, then it go to the ready stage. That means this model is ready for real life cases or practical questions. I normally give an example like why machine learning is similar to human learning. Think about if you go to a school, no matter which stage. It's like you have teacher, you have textbook, you have some questions in this course, you have a structure. And then this process, you need to, the process regarded as a training process. And during several courses, after several courses, normally the teacher will give you a quiz. It could be sudden quiz at the beginning of the course, and I say, okay, kids, let's have a quiz today to test whether you learn good enough from the previous courses. So this is a validation, and after those small quizzes, and at the end of the semester, you will have a final exam, and that can be regarded as the testing stage. And if you are in the higher education phase, and after testing, that means you could graduate. So that means you're ready. You will face the yeah, the real problem. You need to find a job and then apply your knowledge, your skills to the real questions. But if you fail the final exam, then normally you will be sent back to do a resit, or if there is no resit opportunity, you need to go redo exam, like when the new semester, redo the course when the new semester comes. So that's quite similar to human learning. So that's why we also put learning here, like it refers to ability of AI systems to improve its performance. So it's I would say the fundamental concept is the same with people, with human learning. That's why of course that's why we call it artificial intelligence. In the next
But can I add something,
yeah,
Shafkan?
please.
Because I fundamentally agree. At the same time, like learning versus the conversation that we were having before, like in the chat, right? Of like what is learning, etc. Here, it really refers to the capacity of the system to improve its own way of predicting patterns and kind of amplifying that, right? So it relates more to like memory, or like right, like how much data it can process and what are the patterns that it can find and how it can, let's say, fine-tune the performance on a specific task. So it's not learning to gain new knowledge, right? Like it's not I'm curious about what I don't know, and instead of thinking of algorithmic predictions for the human, I will focus on something else because I'm curious about something else, right? Like the AI is just doing this task very well. Another thing that I wanted to share is, for example, the difference between, or after testing and evaluating, we deploy the technology. Let's say ChatGPT is trained on large data sets, and then it's tested and over again. And after it's tested to the end, it becomes deployed. So now when you're interacting with ChatGPT, maybe it's recovering some data for further iterations of its testing. But right now, there's nothing in that interaction that you have with ChatGPT that will make the algorithmic rules change. So that's, I think, important, like that deployment after.
Yeah, thank you, Fer. Okay, yeah, in the next slide, we'll talk about deep learning. Deep learning is a subset of machine learning, as we see in the previous this mapping graph. And here, why we put neural networks higher than deep learning, because it's all about neural networks. So it somehow, again, like human brains, we have like those biological neural networks. So in deep learning, the machine tried to simulate the same learning patterns. It also composed of different, different or multiple layers of, we call neurons or nodes. And for different layers or different neurons on different layers, it behaves like a small or microprocessors. So each one can detect something, can learn something. And then with different layers, it has generated a sum of result. And here we see weighted result because different processor or different duration between different layers are different. For example, I want to use an example of like a cat. How we learn cat is a cat. Yeah, think about like you are a teacher, that you are a teacher for kids, and you try to teach them to identify animals, and you show them a lot of pictures of cats and see, okay, this is a cat. And over time, the children will noticing the features of cat, like that how the eyes looks like, those whiskers or mustache, or the ears, the furs, and the size. And you don't have to teach all the cats different types of cat, but next time when the kids see a cat, it will detect or like differentiate that's cat or not. So that's a process of deep learning, and it's use the neural in their brains. And of course, like could you go to the next slide? Let's go. Yeah. So it's quite complex, like it has different layers, like our human brains. So it's not like when we see it, then we directly generate the output, the rules, but rather they have different layers, and also we can see the connection between different layers. For example, the layer 1's output will be the input of layer 2. For example, layer 1 could be this node is for the eyes or for the ears. Then it will give you an answer like what is the shape of the ears and is furred or not, and the size and the texture. And in the layer 2, we also focus on those features and to reorganize like those informations, like so the combination of those like features could be like different ears of a cat. So we saw this information. You don't have to know like all the cats. It's not like when you are young, like you will be shown like flashcard. This is cat. This is dog. And next time, if you see another cat, like a black cat or more difficult leopard cat, or like a Garfield cat, which is animation, then you don't know is this a cat or not. But with the neurons like networks learning pattern, the brain or the machine here will learn the patterns and to gathering all the similarities or the features, and then generate the output. It's cat or not at the end. So this is how deep learning works. So to summarize, it has neurons. There is the microprocessors of the machine of our brain, and it has different layers, and it has input data like those images here or pixels, and it has multiple layers. We only show here 2, but it has could be millions, and it has a output layers and also the weights between the different layers, the relationship, because the eyes cannot, the feature of an eye cannot be the same the feature of an ear. Let's see like that.
Maybe just to pose like a reflection question, Shaukan, because we talked before about the supervised label data and unlabeled data. So when Shaukan here is talking about how on layer 1 there is the first kind of input that is decided, let's say, for example, the lines of a figure, and based on that it goes that let's say yes or no, it is a line, it becomes the output for the next layer, but there is no human labeling there, which is why this is called deep learning or hidden layers, because there is no labeling of humans being like, yes, that was a line, or yes, that was a cat, right? So it was just something that its own output becomes the input for the next. So yeah, I just wanted to share that. Relates back to what you said before.
Yeah, thank you for. Okay. So remember in the deep learning, we also have different models. One is called discriminated models, and another called generative models. And also in generative model, it has, for example, large language models, and also generative AI like ChatGPT. So that's the difference. So discriminate models is only for more specific purpose. So it learns from the relationship between labels of data points, and it is supposed to classify or differentiate some data points. For example, like what I mentioned, a cat or not cat, or dog or not dog. So it's the binary answer. So so right or wrong, or yes or no. But generative models is it learned the pattern in the training data, but at the end it also can generate new things. For example, simply talk about cat. So we learn what is cat, and next time when we see the cat, we can distinguish whether it's a cat or not. But for generative models, it can also create a new cat. For example, you teach a kid those are cat. In next time in the painting class, in the painting course, okay, you ask a kid to write or to draw a cat. The kid can still do that. So this is generated models. So because they already learn with this cat by observing and or with these rules or algorithms and this like hidden patterns. And yeah, if it's needed to generate a new cat, it can do that. So that's generative models. So that's the difference between those two models. And of course, like some cases like Midjourney or DALL-E of ChatGPT or of OpenAI is like it's an image generator. That's the a case of like it not just generate text or word, but also images. And also I think it's not in the market, but already released the beta version, the Sora. So you can also generate videos by like just input the text or prompt. And also I think in the future the generative AI will be more and more intelligent, or it can be called super intelligent, and can do better than humans. So that's the future of AI, or that's the future of generative models. I would say that's yeah, that could be very powerful or even scary. I also remember people mention this word scary. Yeah.
Yeah, but also like, and this is a very heated discussion, right? Like the super intelligence machines, they're missing context and they're missing sentience. So that is not here for a long, long time. Thank you, Shokan.
Thanks for.
Yeah, if you have questions, please put them in the chat. I think we can have the chat a little bit more of a live section. I already see some comments, great, shared by Bibi. So just go and explore a little bit there. So like a little bit of a recap, what Shaukan just shared specifically about deep learning had to do with image recognition, right? And that's a very specific field within AI, convey image recognition. And I think it can be easy, none of this is easy, but like a little bit simpler to understand how a program can codify pixels into numbers. But we're going to go to a field that's a little bit more complex, which is generative AI, specifically thinking of large language models, prompting, so how to ask better questions, randomness versus specificity. My colleague Noyan will share some strategies and some prompting patterns. At the end of the session, we're also going to share a cheat sheet that we have for you for creating some good prompts. But first, again, from my side, a reflection exercise. So I'm going to read you a story, and I want you to try to get the meaning of the story. It's Friday evening, and Sarah is having a weekly dinner with her parents. At some point, she casually mentions that she might skip the annual family holidays to catch up on some work. Her father paused eating for a moment, held his breath, and continued eating without saying anything. Her mother smiled and nodded. That sounds like a responsible decision, dear. After the weekend, Sarah booked the tickets for the family holiday. So this text describes a situation, right? There's a family dinner and some plans are communicated and made in a different way. However, the deep meaning of this story is hidden behind the subtleties of language. Why did the father stay silent? Was he angry? Disappointed? Was the mother, for example, trying to calm the atmosphere, or was she being sarcastic? I tried my best to not give any intonations of the reading. But so why, for example, Sarah, after saying she didn't want to join the family holidays, booked the holidays? So there's a lot of implications there that unless you were a member of that scene, maybe you don't know. And if it's hard for you to know the exact intention and the meaning of that situation, imagine for a computer program, all the things that it needs to know as context to be able to understand, right? Like, no, Sarah bought the tickets because her father disapproved and her mother was being sarcastic. It's very simple. So of course, like it's a little bit more complicated how large language models are, but words are, they have meaning based on the context that they inhabit. So similarly to images, there's a large data set, large language models or large models of language that kind of archive a lot of words and semantic, so not only words and languages, but also structures, grammatical structures, which words are verbs, which words are pronouns, etc. And also semantic areas of meaning. So if you think, for example, of the word power, maybe for most of you, power relates to power dynamics or power in a political sense. But if this was a talk with in the field of engineering, maybe we would be talking about power in electrical engineering sense. So already you can understand like how semantics are like kind of these realms of meaning. So for a computer to understand the relations between words and their meaning in context, it has done a little bit of like a word processing vector, right? Remember in the beginning, I told you that all data has to be converted into numerical input. So it's really complicated, but basically they put in a three-dimensional vector, or maybe more than 3 dimensions, words in relation to each other. So they create semantic fields and connection between them. And in terms of vector, artificial intelligence now, especially through deep learning, it has the capacity to hold the meaning of a word and then sum it to the next word it has next to it and to the next one it has next to it, and that for a whole text, right? So it can really be specific about what is the meaning of the word power when we have a paragraph about power dynamics in the work context versus if we have power, I'm so bad at like engineering stuff, but power in electrical things in the house, right? So, but still, even generative models, and maybe you have tried it already, when you ask ChatGPT, write my email, it's not the most intuitive, like humankind, and there's a lot of context missing. You would think this is not how I would write, or this is not how we would communicate to each other, because there's a lot of context missing. In that sense, you can think of large language models more like a really big archive, right? And so when ChatGPT is creating, generating new content, and I do new as a quote unquote, because it's simulating a potential answer based on what it has learned before of patterns. And because of this and how semantic, let's say, realms of meaning are mapped out in these large language models, prompting becomes a really important tool or skill to make use of these large language models archives. I see potentially a question. It's interesting to think also of the difference between written language of oral language. Exactly. Because even if I read in my story, right, I try to keep it a neutral. What is neutral? I know this is another conversation that does not exist, but try a neutral tone. We have tone, subtleties, facial expressions, body language. There's a lot more to read than text, right? Voice inclinations and intonations, if I whisper it versus if I yell it, right? Super great idea that you had, Sarah. It's very different. And so that's, I mean, going kind of back to Kant, AI technologies don't have the sensing and the perceptory still capacities or faculties that we have. Situated knowledge becomes really important, right? Situated knowledge, as we all know, will be the best because it's pluriperspective, the best one to follow. So anyway, I will leave the prompting part to my colleague Noyan. I will do it myself first, and then you can tell me next whenever you want.
Yeah, thank you, Fer. So yeah, as Fer displayed, it was a really sort of interesting exercise in understanding how we make meaning. So all of this process of how we understand this, for example, body of text, depends on her little performance, whether she has her eyebrow raised, whether she has her tongue in cheek. But it also depends on how we decode it, what kind of day we are having. What do we understand when we talk about family? How's our relationship to our father, to our mother? How much sunlight did we get today? How happy are we? How sad are we? All of which are irrelevant to the machinery. Yet again, the machine has to provide you with an answer or ask for more input. So, so there's a dilemma that the machinery faces. It has to provide you with an answer, although it's not really dexterous or creative like a human being is when decodifying a message, a body of text. So how does it do this? Next slide, please. So as Fer briefly explained, it processes textual language word by word, literally, and generates textual language or other formats. Next slide, please. You have to go one by one. Bear with me. So it learns patterns and structures to predict the outcomes, as Fer stated, and the context is given by the patterns it has learned and semantic realms. But the context is also given in the patterns of the input, where prompting comes into place. So it learns, and we use learn in quotation marks because we are really sort of we don't want to go into the deeper conversation of whether a machine can learn, understand, converse, or whether those are specifically human traits. We are not going into that discussion right now, but it learns, let's say, for the sake of keeping things simple, let's say it learns from books and internet and simulates, generates plausible responses depending on the structures and patterns that it has learned, but also depending on the patterns of how we ask questions or how we assign it tasks to. So next slide, please. We can think of prompting as stating questions or assigning tasks or providing any sort of input, actually, or instruction to a large language model or any kind of generative AI to basically optimize our output, to have the output as we want it, to maximize its effectiveness, designing the input as well. For example, we will see how machines can actually help us get better in our prompting as well. In addition to making actually sense of our input. And how does prompting achieve these? So as we said, the large language model generates a word-by-word response. And it, quote unquote, again, learns human language from the internet, which is something we have to think about very critically as well, because not everything on the internet we take into consideration without looking at it critically. And of course, large language models, in order to be somewhat reliable, they have mechanisms of actually processing all the information that they have, quote unquote, learned from open sources. But how these sources are sort of posed and positioned within all this digital realm also affects the large language model and how it creates outputs. So through their word-by-word prediction of our inputs, the large language models define the context for themselves. So instead of relying on their socioeconomic status or how they understand the world or what their personal experiences are, and so on, they merely rely on word-by-word predictions, and they merely rely on structures and patterns that they are forced to learn, or that they are sort of learned by themselves, sort of, quote unquote, organically, let's say. Next slide, please. So when we think about prompting, there is a sort of dichotomy between randomness and specificity. A randomness in a large language model is the difference, the discrepancy between the outputs for seemingly the same prompt or literally the same prompt. So a large language model can, yeah, my author is really sort of stepping up its note-taking game. So the large language model might respond to the same question differently in a couple of hours, although it would be like literally the same question, and we will explore this a little bit more. And it usually does this if it's provided with open-ended questions with little context. So and this randomness is by design, because the large language models should be able to should be able to provide actually different answers, because otherwise it would be just like a traditional piece of code that generates the same output when it's provided with the same input. So it would be ones and zeros all over again. But this randomness is sort of by design engraved in the large language model. So you can, in contrast, you can achieve specificity in a prompt by either choosing specific words, or you can explicitly tell the LLM that it has to be specific, or you are asking for something specific, or you are assigning a very specific task in format or content. So specific close-ended questions, context, and specific output requirements actually are needed to achieve the specificity. Next slide, please. So as an example, we can think about this prompt structure that tells the LLM to act in a certain manner and give some instructions, provide some input data and output data. We will share these examples, of course, with you after the presentation. Next slide, please. So when you talk to large language models, think of ChatGPT or Google Bard. Bear in mind that it's a continuous process. So you might need to refine your prompt, and you can ask the large language model to help you out with this. So it is a continuous process, and you should be using the advantage of being able to get speedy responses and reiterate and refine your input. Bear in mind, you can achieve specificity by feeding date and rules to the large language model. And you can set a root prompt to provide ground rules and then sort of modify it a little bit. And we will take a look at the overview of prompt patterns a little bit. So next slide, please. A prompt pattern is basically a pattern that we use to achieve a specific output. So, for example, a persona pattern might be a prompt that starts with act as a such and such, act as a computer engineer. I will ask you this and this, and you will tell me this and this. Or a question refinement pattern. Or a flipped interaction pattern. For example, I'd like you to ask me questions. Actually, you can make the large language model ask you questions in order to achieve a specific goal. Or you can ask the large language model to come up with alternative approaches or a better version of your question. Next slide, please. So here, this is sort of a cheat sheet to achieve for prompt patterns and what type of outputs you can achieve with each prompt pattern and what pattern is best for reaching specific end goals. So, for example, if you want to interact, then the example that I just mentioned in the flipped interaction pattern would be the best prompt, or the gameplay pattern, or the infinite generation pattern. Next slide, please. Or if you would like to improve your prompting, improve how you provide input, you can have the question refinement pattern or the alternative approaches pattern or similar other patterns. But now I want to take a step back and sort of ask you something. How would you, via prompting, how would you be able to determine bias in a large language model? So would you use specific prompt patterns, or would you go for maximizing randomness, for example. How would you try to, let's say, pinpoint the biases in a large language model? And is this something that can be optimized as well? Okay, so FAIR would be using both and cross-reference. So actually, when we use prompt patterns, as we said, we are sort of, we are using, so could you confront it about bias? Actually, let's say we can, but yeah, you would instruct it to identify bias. So, but these prompt patterns that are really focused on optimizing the output might not help us out that much. We might need other patterns. So, for example, comparative patterns. If I can share my screen real quick. I don't know. How do I request remote control? No. Okay. So I will share my screen. Host disabled. Okay. So Gigi, if you can add me as a co-host, I can share my screen real quick. I just want to share a small example of how we can pinpoint this, via prompting. Okay. So way of doing this, sorry. Did I freeze? I think I froze. Yeah. Okay. So a way of doing this might be asking the same question in different languages. So I asked ChatGPT about Atatürk, which is who is the founder of the Turkish Republic. I'm doing it. I'm using this specific example because it's my native language, and I'm able to pinpoint biases a bit more dexterously. So an interesting thing happens. Like when I ask it in English and in Turkish, it gives more or less the same response, with one exception. This last sentence in Turkish is quite different from the last when you compare it to the last sentence in English. So the English answer ends with Atatürk's legacy being deeply ingrained in the Turkish nation, and his leadership continues to be a pivotal point. So it's very important for Turkish history. But actually, the Turkish output mentions great respect and appreciation, which is not engraved in the English version. So when I speak Turkish to it, it assumes that I would be more or less maybe pleased with this sort of response, or like this response generates more positive sentiments in me. Bear in mind these type of small interactions, where you can share the presentation again. These type of small interactions are really on the outmost layer of algorithmic criticism and pinpointing bias in large language models. These are just little thought experiments that you can play around with and with the large language model. Next slide, please. We have a different sort of critical prompt as well. So you might ask it to describe the day in the life of a nurse. Next slide, please. And then the day in the life of a female nurse. Next slide, please. And then the day in the life of a male nurse. And then somebody, Gigi, for example, mentioned instructed to identify bias. And when it has produced, if it has produced these, all of these outputs for the prompts that we generated, we can actually, instruct it to identify the bias, make a critical analysis, a textual analysis, and ask why did it choose those words, and what inherent biases did it recognize in its own output. So this is a little thought experiment. Bear in mind, let me repeat, this is the very this is critical prompting on the very out layers of LLMs. This is these sort of little interactions are in no way replacing transparency in large language models and so on. The bigger picture, the bigger gains, or the bigger accountability, of course, lies in there. And I will, give the stage to Per again to wrap up.
Thank you, Noyan. Yes. So as a very quick wrap up, because I know we're all yearning for the conversation with the photos since it's already happening in the chat. We can think that AI is a technology embedded in sociopolitical context. We know it has its limits based on how it works, the data it uses, and its capacities. We can use it critically to assist us in making decisions, and some decisions are better left with us, context-wise. But we humans are responsible for its uses, regulations, and effects. So we don't displace the accountability, right? The urgent conversation we need to have about AI is who gets to decide what this technology is for and how to use it, so it benefits the world and not a handful of people. And finally, I mean, this whole intention for the sessions is to have an open source conversation about AI. What can we do with it? How to use it? So yes, please stay in the last, because we'll share a link for you to fill a survey so you can have access of all these materials, cheat sheets, and the PowerPoint, etc., in a PDF version. Coming up in our learning series, don't miss out in these conversations. And Lutze, if you can share the links in the chat. We have some really cool sessions about communication, about data, about ecosystems of responsibility, and regulatory landscapes, which I think are very relevant for us. And I mean, with that a little bit in mind of technology is what we collectively make of it. I want to give the floor to Bibi for the AI in conversation. So we will also share the photos. I stop sharing, Bibi, so you have the floor. Yes.
Thank you so much, Fer, and everybody, Gigi, for making this happen, and to all the others who shared their knowledge today. So I'm not alone today. I'm here with my magical colleague, Kenneth, who is our digital governance guru, let's say, in Forus, as well as a dear colleague, Nina Sagma, from AIPP, so Asia Indigenous Peoples Pact, who will also be joining this presentation and sharing from her experience. Ciao, Nina, super nice to see you. It's quite maybe late where you are, so thank you for making the time. So we will just, let's say, in the next 10 minutes, a little journey through why the manifesto was developed, with whom, and maybe with what questions behind it. So perhaps we can start with the disclaimer that most of us involved in the manifesto, we were more than 50 organizations, we're not experts in AI, not experts in machine learning, and some of us not 100% involved in digital rights. But we brought for the manifesto this intersectional approach to technology, to rights in general, and to the connection of AI to what's larger, to the larger world, to us as humans, to us as activists, especially as civil society organizations and the civil society sector. And one of the main objectives of the manifesto was just to share stories. So not so much to share too many recommendations, but just to say, this is how artificial intelligence and machine learning is affecting us in our daily work as civil society organization, as activists, And as a result, we collected stories from around 20 friends and colleagues, all with different approaches. For example, some of the stories are on the legal framework of AI across Africa. Other stories are about machine learning for peace, so using machine learning to predict changes in civic space. Other stories are from artists who are experimenting with AI, and they maybe write a prompt and about women, and all of a sudden there is a super sexualized woman who's like a cyborg, and at the same time, completely, taken out of her context. So it's really sort of a diary from various people who just wanted to share their experiences. And I even see that some of the participants today, like Alain Serge, bonjour, from Repongak, etc., they have also contributed to the manifesto. So the idea was really to start this conversation, to bring people together and to think, what is AI? How does it affect our work in our lives? And some of the recommendations and some of what came out of this process were basically a couple of things. The first one they need, and this is why we're super grateful to RNW Media and Partos, they need to bring and create more spaces like this one, where people can just, without any censorship or anything, talk freely about artificial intelligence, ask questions, have dreams, have visions about what artificial intelligence can look like and how it can help us in our work, but at the same time also collect real life stories and experiences from activists, and I think Nina will be sharing more on this, and from civil society organizations of what are the risks, what are the actual problems with this technology, and how can we turn those risks in opportunities. But this is not just with a magic wand. It starts, and I think Kenneth will talk a bit more on this, with civil society space, citizen space in digital governance forum. If we are not there, nothing, we can talk as much as we want, but nothing is going to be influenced. Or opening up, of course, the digital sphere as well. And yeah, we hope this is an ongoing process. We are still talking and collecting experiences, talking to each other on this. And I will now pass the mic to our colleague Nina, who is here, who can tell a little bit more about what is happening in this big fora and why civil society has a big role to play in AI. Ciao, Nina. Thank you.
Thank you, Bibi. Am I audible? Because I don't have any other equipment, but are you able to hear me clearly? Okay. So I've been asked to talk a little bit about why it's important for civil society and activists such as ourselves to be involved in AI, particularly governance and development. And for me, I think when I started this conversation, thankfully with Bibi, when we both, we sort of collaborated on this Digital Rights Festival last year, and we both realized that there's a lot happening that we don't understand. It's very overwhelming. We all know that technology, for example, is a very gate-kept space, particularly dominated by cis white men, or men in general who are, in charge of pretty much getting to decide how that technology is built and how it's going to be used, and primarily focused on profit margins, not on the sort of welfare of societies and human beings. So for me, I think it's simple, and I kept kind of delving deeper into this conversation and went down many rabbit holes. And I think for me, the simple answer was simply to decolonize. As an indigenous person, I think, I've always told people, indigenous people have always been the sort of open labs for governments to test their theories of dehumanization, of genocides. Everything has been previously tested on indigenous peoples, and technology is no different, right? In the ways that it is being used to currently categorize and contain politicized identities like indigenous people across the world. And so I think for all of us, it's obvious that if we are to be part of this conversation, we need to transition and ensure that we transition from a power-centered world to a justice-centered one. So I mean, you know, I wanted to kind of focus on decolonization and what it means on a granular level. I think for me, it was looking at technology, AI through the lens of empire as intersecting systems of oppression. So in a sense, AI cannot be viewed in isolation. In a deeply connected world, we seem to be living in more and more polarized societies, right? Being used as data ourselves to generate more data and live in this constant loop after loop of realities, multiple realities that validate our biases, that dehumanize populations using language, particularly. We're currently seeing narrative wars being played online, hugely funded disinformation campaigns by governments, all of which have real life consequences, which are only going to imagine, you can imagine what AI is going to do when it comes, I mean, when it's going to get deployed in that sort of massive scale. And then we're seeing well-documented genocides on the ground, right? So existing forms of technology just reinforce a narrow Western and Eurocentric idea of beauty and bias. And it acts as a bridge to emerging technologies like AI. And so while technology is meant to connect people, its governance and policies all, you know, inevitably widen existing inequalities and impact unequally those who are connected, poorly connected, or disconnected, like indigenous people, some of whom who do not even want to be connected to the outside world, right? And so there's a huge larger question of consent about abuse of human rights. You know, so that is another dimension that is interesting to me. So it's become obvious that it's important for civil society and activists to be involved, to have a say in its creation and deployment. Because as I see, the potential for, you know, abuse of human rights is immense. So it merits examining the elephant from different angles, informing ourselves in various contexts and possibilities. And ironically, I also asked ChatGPT for the answers to this question, and it wasn't wrong. So it mentioned, broadly speaking, it not, of course, you don't expect context, you don't expect nuance, you don't expect localized points of views, but it basically said that, you know, there's representation that is a consideration, there's ethical considerations, accountability and transparency, human rights, blah blah blah. So it goes on and on, but like I said, it doesn't give you nuance. It's not human centered at all, right? So obviously the goal for us is that how do we make this thing more human, and more sensitive to larger groups, especially the global majority, right? So I'm hoping that AI doesn't reach a point where it can write beautiful poetry that speaks truth to power. So I'm going to end with reading you a poem by an indigenous poet called Abhay Haha, and it's called "I'm Not Your Data." So it begins with saying, "I'm not your data, nor am I your vote bank. I am not your project or any exotic museum project. I am not the soul waiting to be harvested, nor am I the lab where your theories are tested. I am not your cannon fodder or the invisible worker or your entertainment at India Habitat Center. I am not your field, your crowd, your history, your help, your guilt, medallions of your victory. I refuse, reject, resist your labels, your judgments, documents, definitions, your models, leaders, and patrons, because they deny me my existence, my vision, my space. Your words, maps, figures, indicators, they all create illusions and put you on a pedestal from where you look down upon me. So I draw my own picture and invent my own grammar. I make my own tools to fight my own battle. For me, my people, my world, and my indigenous self. Thank you. I'm going to leave you with a link to an article that I wrote for Cultural Survival that looks a little bit more on the impacts of AI on indigenous peoples. But thank you, Bibi. Thank you for having me.
Thank you, Nina. That was beautiful. how else to end a session on AI but with a poem, huh?
Esatto, grandissima Nina, as always. We also have here Kenneth, last but not least, who will also provide a different perspective on this whole conversation linked to what Nina was saying. Maybe not a poem, I don't know, unless unless all of us had, and I don't know, Kenneth always has a lot of surprises. So perhaps just to end the session, we could just touch on some final remarks on digital governance and how to make what Nina say happen in some big or smaller spaces. I don't know if Kenneth, you can hear us. Oh, I do not see him. Let me see. Ah, yeah, then maybe it's really destiny. Well, no other more beautiful way. So Fer, back to you.
Yeah, thank you. I mean, there's, I think, a lot of resources shared in the chat. And I think these points, for me, when I read the Ethical AI Manifesto, the first thing I noticed, it felt like a process and like an open-ended one, starting of a conversation that depended on many voices. And I think as a form is very poetic. And thank you, Nina, for bringing poetry back here. Not only in the sense of poiesis as something that gets created, but rather where it comes from and the feelings and the desires, the dreams. I think we're trying, I think I speak maybe for most of us, we're trying to envision and dream what are better ways of being in this world that can be healing towards systems and ecology. So potentially some post-humanism there on top of feminism and decolonial and a lot of layers of work to kind of heal for the systems of oppression that we have experienced for hundreds of years. So thank you for bringing this back. There in the chat, I call out, there's Nina is sharing the articles that she was mentioning. And there's a lot of resources. I will make, well, actually, I would need to ask Gigi to do this because the Bartos is doing the Zoom now. But if you can collect the links and send them to me, and then at some point, let me try to see here. Oh yeah, I'm gonna copy it and paste it again in case anyone needs to leave now. But we've created a survey for you to give us your point of view on this session and on future sessions, but also as a way of keeping connection. We will not use this information to share anything else than the sessions that we're gonna have on AI. And also so that there's a button that you can click yes or no, if you want to receive the PDF of this session with the explanation text below and the resources and the citational gratitude that we owe for any creation of any, especially learning endeavors. There's a lot of knowledge that is building up on the knowledge that we're trying to create. So thank you, everyone. It was truly an inspiring space to have. I feel really lucky. And I'll be happy to connect with everyone. Gigi, I don't know if there's anything you want to mention before we close off.
Just a huge thanks for everybody who contributed to this session. The facilitators, the speakers, also the ones who are behind the Forest Ethical Manifesto research. I think like this body of work is so inspirational. And I think it really brings us back to the essence of understanding why in the first place we as CSOs, as activists, as social justice advocates need to be involved with and informed with how AI works. So thank you a lot. And I can just say, subscribe to the upcoming AI learning sessions, and
please
hope to see you all there.
Please reach out also if you have any questions regarding to how to subscribe, or if there's ways that we can support in the process of subscribing. Please just contact us. There's always a way, and also we just it will happen at the end of every month, so the last Tuesday of each month, except July because holidays, and that's important. So yeah, I look forward to see all of you. If you liked it, share, and most of all, just keep on having these conversations. Let's lose a little bit of fear.
All right. Wonderful. So I think we can close up the session.
Yes.
All right.
Thank you, everyone.
Thank you, everybody, and have a wonderful rest of your day.
You too, Gigi. Enjoy the mountains.
Thank you,
you.
everyone.
Thank you, everybody.
Thank you,
Ciao.
Gigi.
Bye.
Ciao a tutti. Ciao, Nina.
Do it, team, do it.